Okay. Hello, I'm Tisham. I'm going to talk about DIY energy monitoring. I make some energy monitoring boards, which I will pass around. Okay, let's go to next. Get used to this. Arrow keys? Yep, okay. So forward. So I'll talk about energy monitoring, and I wanted to build an energy monitor which was easy and affordable. I looked around at what I could get off the shelf. There's FRG, there are a lot of options out there in the market, but none of them was easy, none of them was cheap, which was sort of $50. I probably have spent more than that making it, but I sell my prototypes, which is sort of what I'm going to talk about. And it gives you control. You can bring the data into your own server. You can have it in-house. You can write your own firmware, monitor how often you like, or how less often you would like. So this was done sometime last year, and then you can see the recent trends in South Australian energy prices. And with the whole blackout thing and stuff, it has become a big story. Compared to the rest of the states, South Australia has some of the highest energy prices. You can see very huge spikes. This is due to spot pricing of electricity when gas turbines have to be turned on, and it gets slugged a lot. And in a bid to save electricity, everything was getting turned off in my house, and I wanted to have my server on and so on. So I just wanted to get some quantitative values on how much energy different appliances were consuming. So rather than turning off every appliance you have, just track down which is the bad one and replace it if possible. Or if it's your TV, just don't watch TV. Entertain yourself. Otherwise, maybe the iPad consumes less energy. So these are the people who have helped me get where I am today. That's me. I try to help myself. I have got somebody who helps me solder for a bit. He's a student, and while he was looking for work, he would come by on weekends and help me do my very intricate soldering. I'll send some stuff around while I'm talking. You can have a look at my work. So this is a prototype, and this is sort of a soldered final version of the same. I pay him sort of a casual rate to pay, and he was saying, oh, if you were paying this rate in China to get people to do soldering for you, you'll have thousands of people turning up. So manufacturing things in Australia is not easy, but it's worthwhile doing it. And Rani is my wife, and she sort of likes data. She's a statistician. And I built this solution sort of to satisfy her need for knowing what is consuming how much, when. And all the prototypes are built using sort of open hardware facilitators, low-cost, low-volume PCB and component suppliers. I know you might be familiar with some of them. Osh Park in America, Sud Studio in China, Hakvana in Mitch Davis, who is in Melbourne, and some other usual suspects for parts. So this is sort of the timeline of how I went from sort of wanting to do it to doing it, and going through various iterations. I started sometime last year in August. I built sort of a prototype on a breadboard, and then I built a PCB and then wrote a blog post about it. And in October, somebody wanted to buy one. So I sold my first one to UK, and then that sort of paid for my batch of PCBs, so I could make another version, and so on. And this was a presentation I prepared in July. So in July, I had around 50 orders from 15 countries, and now we are in November, and the number is about 100. So that's good. I have gone through 4 or 5 iterations now. I'm trying to bring everything into a single board, try to get some casings built, maybe get some help to write some manuals so that it looks more professional and so on. It didn't start out being a product. It was just for myself. I was sort of doing well, as they say, scratching an itch, trying to do something for myself so that I would be able to solve my own problems. But a lot of other people have similar needs, and there is nothing in the market which does address it. And there are a lot of enabling technologies around which let me build a solution for them. Sort of, you can see the breadboard going around. In October, I had what we call a through-hole version, where you solder all the parts through. And then in February, I had a sort of a stacking solution with a screen and everything. So going from one design to another takes a bit of time. It requires a PCB design. You have to wait for around 3 weeks for the PCBs to turn around, even from China or the US. I wish there was a small-scale OSHPark-like service in Australia, which there isn't, which I hope there is a niche for somebody to start it. Yeah, so there's a fair bit of round-tripping before you can go from one prototype to another. And in addition to building the hardware, you have to build firmware or software that runs on it. All this is sort of uses the ESP8266, which is a very low-cost Wi-Fi and microcontroller on a single chip. And so this Node MCU board, do you have a pointer? Okay. This board here is a Node MCU board. This is the ESP8266 chip. Yeah, in volume, you can get them for like $1 each or something. That's great for Wi-Fi enabled chip. So yeah, so that sort of shows the hardware iterations. So I'll talk a bit about the technology behind the way the energy monitoring is done. So there are a few basic components. So I talked about the ESP8266 already, which provides Wi-Fi. The ADC is an analog to digital converter. When you're measuring mains electricity, you have to do a bit of signal processing because the waveforms need to be sampled fairly often to get an accurate measurement. And then you have to send the data somewhere. So nowadays, it's the big buzzword is the IoT, Internet of Things, but it has been around for a while in industrial environment especially. It was called machine-to-machine communications. So it has been around, but it sort of lets you send the data out of wherever your measurement is taking place for permanent storage and analysis and whatever you want to do with the data, take action. So basically, before it was an open loop system, now you're trying to close the loop so that you can make it more efficient. So the things you need are capturing and digitizing current and voltage waveforms. So the current waveform is captured using lots of different things. In a industrial smart meter, it will be a shunt, so which is essentially a very low resistance piece of copper, and you measure the voltage drop across it. Because my design is meant for more consumer, and I don't want people to operate with high voltages. I can't really safely do it myself either. So, so you capture and digitize the current and voltage waveforms, the voltage from a transformer. Then you compute the RMS voltage, current, true power, whatever parameters you want to compute. So initially, I was doing all these calculations on the microcontroller, but it loads up the microcontroller, and the calculations are not as accurate as it could be if you had a dedicated processor for it. In my latest design, I use a DSP from Atmel, and there are a lot of other options now in the market for doing these calculations on a dedicated chip. And they cost a couple of dollars each because they're designed for commodity deployment as well. And then you use the Wi-Fi to upload the data for permanent storage, run it through some analysis and trend software, maybe use that to automatically turn off your heating when so on. So I've gone through these already, capturing current and voltage waveforms, power computations. The data upload is interesting in the options you have these days to upload. So I built my first demo using ThinkSpeak, which is a service provided by the people who make MATLAB. It's famous in engineering community, MATLAB. So basically, you send data every 20 seconds to their server, and they promise to keep it for perpetuity, or however long they will exist. You can choose to send it to your own server. There is also another thing I was trying recently called Blink. Blink has like a little app which you can put components together on your phone to make a little dashboard, and you can host your own server and so on. And these days, there is a lot of research going on this last topic here, which is called non-intrusive load monitoring. You can analyze the time series to auto-learn which appliances are being turned on and off, and what kind of, based on their usage sort of pattern and just the actual power they consume. So that are sort of some pictures of my setup. It's changed a bit now. If you want to see the in action, this was deemed unsafe for use here because it has got live single insulated live cable. So it's actually double insulated in the demo I have on my bench. I have a little stall number 33, if you want to see it in action. I was going to bring it all here, but yeah, it's still there. So if you want to come and see it in action, you can come and have a look there. Some graphs of how it looks when the data reaches ThinkSpeak. You can make it fancier. You can make little dials. You can do calculations. MATLAB is making the analysis capabilities of MATLAB available via ThinkSpeak as well. So you could perform NILM or any other algorithms, learning algorithms on MATLAB if you chose to using this data. A bit of dollar talks, this is what it costs to make one of these energy monitors. And I sell them for $30 or $50. And sort of the principle is you sell things for around 2 or 3 times what it costs to make them. PCBs in my soldering oven, lots of parts, assembly, and alternatives. These are pretty good alternatives that are out in the market. The people in Effergy have a proper consumer-grade solution. Emon Pi is a sort of a do-it-yourself solution out of Wales. I've been doing some work with them. They're sort of moving from the Raspberry Pi to a smaller, cheaper version as well. And yeah, if you have any other questions, and here's a little blurb about us like trying to manage our grid together and sort of manage our consumption so that we can reduce our usage overall and not have these power outage scenarios and so on. Yeah. Any questions? Am I over time?